Hi. So chat interfaces are all about talking. And when we actually want to do stuff, the best we can get out of them are clear instructions. Previously tackled this problem with creating workflows in NA10 and connecting tools. What if we gave our chat interface access to a real calculator? Then when we're talking to a generative AI, it knows that it has access to a calculator to do the simple math. And it's wider than just a calculator. What if the generative AI had access to a whole range of tools that it could use at any given moment? That makes the AI super useful for actually doing stuff. All of this can be done with small models running locally on our machines and completely private to the outside world. This is all possible with something called MCP. So today, what we're going to be doing is we're going to learn what MCP is, how it works. We're going to set up a calculator as a tool and connect it to our chat interface. In this case, it's going to be LM Studio, all running locally, all using small models. No coding experience required. So let's get to it. MCP stands for Model Context Protocol. In simple terms, all that means is it's just a way for our generative AI to talk to and communicate with other applications, whether that application is a calculator or a calendar or a browser or any other tool. And yes, that other tool could include NA10, which is something we're going to look at in the next video. But for now, we're focused on the calculator as a simple use case. Now, to start our exploration on MCP, let's start simple with a user interface. See, humans like you and me, we have graphical user interfaces for the apps that we use. This is an example of LM Studio. It's an app that we looked at previously, if you remember. It's a way of downloading and using local models. If you want a quick refresher, it's worth going back to the previous video. I'm going to assume familiarity with the app going forward. But you'll notice on LM Studio that it has a number of tabs along the left side of the screen. We've got chat, we've got developer, we've got my models, and we've got discover. So if you want to chat, we go to the chat tab. If we want to discover new models, we hit the discover new models tab. And each of these sections has an interface specifically designed to make that task easy for humans. But what if the user isn't human? What if the user is an application? Specifically, what if the user was a developer needing to coordinate communication between different applications? For this case, it is still technically possible to use a user interface, but it's not really optimal. Enter API, or rather an application program interface. In other words, an interface designed specifically for applications or for code to use. Now, here's an example of what the API looks like for LM Studio. So if we go to developer mode, don't worry if you think this all looks really complicated. The main things that you need to focus on are this reachable at, that's the URL, and these are the endpoints. So these are equivalent to the tabs in our user interface. So if we want to get a list of models, we use the model endpoint. And if we want to use the chat and we want to communicate with the chat and use the AI model, then we use either of these endpoints. And so the endpoints are equivalent to the human interface tabs. But how do we know what each of these endpoints does? The answer is documentation. And this is example documentation for LM Studio. And the documentation really is vital. Without it, we have no idea how to use the endpoint and what sort of format we need to send data and what sort of format we get the data back when we're facilitating communication. What has all of this got to do with MCP? Well, what if the user isn't human, isn't an application, but is a generative model working on behalf of an application or a user? As before, Language models can technically use user interfaces and APIs. We've even built examples where we connected, for example, Google Sheets to an API in NA10. But this required significant setup and hand-holding. And every time we want the LM to connect to a new tool, we need to go through that similar hand-holding, let it know what the API is, what the endpoints it should be using. And we need to do the heavy lifting in terms of reading the documentation and understanding how each endpoint works. There has to be a better way, right? Enter MCP. And this brings us back to this, where MCP is like the universal adapter to connect to various different tools using a common language, that is natural language. So instead of building custom integrations for each tool, we just let MCP handle it. And what we're really doing is, if we've got our generative AI model here, all we're really doing is we're just giving it access to the API, and we just give it access to the docs. And then now when we ask the AI for something, it has access to both, and then it knows which endpoint to use and how to use that endpoint thanks to the docs in order to answer your queries effectively. When it comes to the anatomy of an MCP, there's really two parts. There's the server and there's the client. Now, when it comes to the server, think of it like this. We've got a tool, and around that tool, we put a wrapper. And in that wrapper, we've got some documentation around it. So the wrapper makes this tool self-describing. That means when the AI comes along, it knows how to use this tool because it's been self-described. So it knows what endpoints to use, how to use it, what format to send data in, and what format it'll get data back. And here's a simplified example of what the MCP server looks like as code. So we've got the MCP tool defined here, and then we've got the wrapper, the documentation, and then this is the bit that accesses the API. Don't worry too much about understanding the code. The key points here is that it combines the available functions or endpoints with clear descriptions of what they do and how to use them. And this is so that the LLM can read this and go, okay, I know what this does. And then it's able to use the right tool or the right function, the right endpoint to complete its tasks. Now, the MCP server is only part of the equation because you can't use the MCP server, this tool, without knowing how to connect to it. So this is where, think of it like a plug. So this is where the client knows how to plug into the tool, and then the LLM is able to use it. So this is really the full diagram of what's happening. We've got our AI here. It uses the client to connect to the tools, which is our server, and that tool is self-describing. And in terms of the client, a client could be made up of multiple clients. So it could be any number of additional clients, each which is plugged into different servers. So that's a server. There's another client there that's also connected to another server. So this is really what the diagram is looking like. We've got an LLM or an SLM in our case, and it's got a list of these clients, and each one of these clients connects to a different tool, each of which is self-describing with documentation, etc. There are a ton of MCP servers already built and ready to use. If you head on over to mcpservers.org, here's a list of some really great example servers. Heads up on this tutorial is not really a follow along. So for the rest of this, follow along with this tutorial, because you'll need to install some frameworks in order to get these servers working. So a lot of these servers require Node and UV installed. So they're very developer centric. Not all of them. Some of them you can plug in with URLs. And in the next video, I will be showing you an example of how we can set up an NA10 server super simple. That will be a follow along, that next video, but this one is not a follow along. So just want to make that clear. Head on over to MCP servers. You get the general gist of what sort of servers are available. And if you do want to go into a developer mode, you can start to install Node and start to install some of these other servers and have a play around. Yeah, the MCP server that I was interested in is a calculator. So here's the command for running the calculator. So if you go to MCP servers, this is our client config, our MCP client config we need to use to plug in to the MCP server calculator. So it's just a single line and then it just runs, but I do need to have UV installed on my machine. So let me just copy that. Right. So now what do we do with this client config? Well, LM Studio has got MCP client built in. Not every tool will have MCP client built in. LM Studio happens to have it built in. And if I go to the chat area and use a socket, we'll see that there's an install integration section. And if I go to install, this is a previous one, so ignore that. If you go to edit mcp.json, and this is our MCP config. So this is the config that we saw earlier on the mcpservers.org site. And it's probably better to look at this on a single line. So let's update this to a single line so you can see how this works. There we go. So that's that on a single line. And if we wanted to add a new server, it's just simple as this. We just give it a name and we can give it any name though, MCP server 1. And if this was an API based server, then we'll have something like URL and then the URL for the server. So server URL. So we just add additional servers by just appending to this MCP servers list. But let's get rid of this and let's save this. And this is our MCP calculator ready. You'll see it on the right here as well. And we can enable or disable it on the right. But I'll go back to chat. Let me show you an example of not using the calculator before I show you an example of using the calculator. I'm using the Qwen 3 0.6 billion parameter model here. It's a tiny model. It's 500 megs size. Runs very quick on my M1 machine with 16 GB. It's plenty for this model. This is some simple math for the AI. Most of these models now have got some sort of calculator built in, so it's using its internal calculator to figure it out. And in the thinking, you can see how it's going about trying to break it down. In this specific instance, it's taken 40.04 seconds to come up with the answer, and it's shown me the working out. So now it's got the right answer. Let's start a new chat. Let's copy this, start a new chat, and this time let's plug in the calculator. So we got 40 seconds to beat, and there we got it. It's less than 7 seconds to get the answer. And here we can see when it called the MCP calculator. So a calculator may not have been the best example because for simple math, most models can figure it out, but they take a while. That was like 40 seconds. I've had situations where it's taken over a minute and it's going round and round and round in circles, thinking how to figure out simple math. Just using a calculator just brings that right down to 4 or 5 seconds. So even if in an LLM and even if a small model and a local model is able to deal with them, we do get some added transparency because it's made a call to the calculator and we got the answer back. And we've also saved some time in terms of saved all of that additional thinking that it needs to do, additional energy that it didn't really need to expend to find out the answer. Why does MCP matter? Well, with a simple configuration, we were able to connect our LLM to a tool, and we can connect it to any other number of tools. Therefore, we can give our LLM access to any number of tools that we've got access to. that we have MCP servers for. And all that can be done very simply. We can add a browser, file systems, database, thousands of other tools this way. But the main reason why I'm interested in MCP server, because in the next video, we're going to be connecting our LM Studio to our NA10. So we have access to really powerful custom tools that we can build in NA10 and give our LLMs access to it. So join me next time.